Welcome back to what unfortunately is the last video of descriptive statistics. So far, we've learned how to read bar charts, histograms, box plots, mosaic plots, and contingency tables. But what if we want to compare two numerical variables and see how they're related to each other? Say we want to see how the number of times Joey Votto gets on base is related to the number of times Joey Votto scores a run, or how many times he strikes out is related to how many times he gets on base in certain games. This question can only be answered through a new concept, correlation. So let's get started by pulling up the dataset and dig in. Correlation is an extremely complicated and very in-depth topic that we're only going to graze so you guys understand the basics of how to understand correlations and basically what they tell you about variables. So with the dataset, we're going to go to Analyze, fit y by x, and because we need two numerical variables, we're going to select in the y column, because we're curious how many times Joey Votto gets on base is related to how many times he scores a run. We're actually going to put times on base as the x factor, and runs are going to be the y response. And we're going to select OK. And this will pull up a scatter plot with a point at every time each of those two outcomes matched up. And now what we're going to do is we're going to go to the red triangle and we're going to select fit line, and that'll give a line of best fit or a regression line that essentially is a prediction of, based on how many times Joey Votto gets on base, what is the predicted number of runs that he would score in that game. And this is a lot of information down here that we're going to get to later in the inferential part of this course that we're not going to use right now. But what we will do is, because we want to get the actual correlation number, we're going to go down to the density ellipse here and we're going to select 95, which will put a density ellipse around what the JUMP program sees as 95% of the data points. And then we're going to select correlation down here. So the first thing that you'll see is that this line, looking at the graph, is positive. It has a positive slope. And looking at the correlation part here, it has a correlation of 0.5 or 50%. And that's a decent correlation. That means that there's a somewhat strong correlation between the number of times Joey Votto got on base and the number of runs he scored. If there was a perfect correlation, that is, for example, if Joey Votto got on base 2 times in a certain game, and every game that he got on base 2 times, he scored 2 runs, and every time he got on base 3 times, he scored 3 runs, that correlation would be 1. Likewise, if there was no relationship, let's say for all the games Joey Votto got on base 1, 2, 3, and 4, and 5 times, there was an equal spread of how many runs he scored, there would be no correlation, and the correlation would be 0. Additionally, if there was a negative relationship between runs and times on base, which is impossible with this example, but let's just say every time Joey Votto got on base once, he scored 3 runs. Every time he got on base twice, he scored 2 runs. And every time he got on base 3 times, he scored 1 run. The correlation would be -1, because every point would perfectly fall on that negative line. And correlations are bound. They can only be between -1 and +1. So a correlation of 0.5 is actually pretty good and pretty substantial. This is the regression equation, and this can be very helpful because it's the equation for this line of best fit, our prediction line of the correlation. So what this is telling us is that R is runs. Runs is equal to 0.03 plus 0.3 times the number of times that Joey Votto got on base. So if we're going to plug in times on base, if Joey Votto gets on base 3 times in a game, 3 times 0.3 is about 0.9, then plus 0.03. So we can round that up to 1. So the regression line predicts if Joey Votto gets on base 3 times in a game, he's going to score about 1 run. And it falls right under that point there. So that's just a way to understand how to read this regression equation. We actually can calculate how to make that line, but we need a lot more math, and that's for another time. So anyway, to sum it up, clearly we see that the number of times Joey Votto gets on base is positively correlated with the number of runs he scores. And really that makes a ton of sense, because in order to score a run, you have to get on base. So of course, the more times you get on base, the more opportunities you have to score a run for your team. So just a quick couple notes on correlation. Even though we're showing that those variables are related, we are not saying that one variable caused another outcome. We are simply saying that they're related. You can get in a lot of muddy water very quickly when you start saying that because two variables have a positive or negative correlation, one variable is causing another variable. We are not saying that. If you want to show causation, you have to set up an experiment where you manipulate an independent variable to see if there's a different response in the dependent variable. But that is not at all what this data set is, because these are just observational games that happened in 2013. And that's all I got for the descriptive statistics portion of this class. We've covered a lot of content in the class, and we'll build on that more as we get into inferential statistics, which involves testing, and hopefully you come along for that course too. So thanks.